Right. Good afternoon, everybody, and welcome back to the second day of Sacla 2020. This afternoon, we will be hearing from 3 papers. Just a reminder that each presenter has approximately 20 minutes to give us their presentation, followed by 10 minutes of questions and discussion. If you have a look at the bottom of your Zoom window, you will see a Q&A icon. If you click on that, you can type any questions that you might have directly into the little question box, and then our Q&A coordinator, which is Mr. James Connon this afternoon, will present your questions to each of the presenters this afternoon. So if we get started, our first presentation is on a paper that was co-authored by Malibongwe Twani, Andre Kalitz, and Margaret Cullen. And the paper is titled Identifying Relevant Factors for an IT Career Choice Model. And the presenter this afternoon is Mr. Mali Twani. So Mali, over to you if you would share your screen with us.
Afternoon, everyone. I hope you can see. Can you see it? I've shared, Ingrid. Is everyone able to see on the screen?
We can see it, but you need to please make it full screen presentation mode.
Can you see?
We can see it, but you need to make a presentation mode, please.
Not a problem. Okay, I'll be presenting the paper. Afternoon, everyone. My name is Malibongwe Twani. I'll be presenting the paper that was written by myself, Prof. Kalitz, and Prof. Cullen. The paper is entitled Identifying Relevant Factors for an IT Career Model. So we'll basically take you the contents, we'll look at the background, the problem statement, the research design, literature review, and the results from the study, and also recommendations and conclusions. So the background of the study, through research, we've seen that there's been lots of papers published on the high employment demand, especially in the IT sector, that there's a greater demand while there's fewer graduates worldwide. And this increase is estimated in one of the studies that it will increase by a further 12% by the year 2024. And we know that within our country, that the IT skills, which includes CS, IS, and IT, has been highlighted for a number of years now as one of the scarce skills. So we've got a serious problem in terms of IT shortage of professionals. So again, when we look at literature, it highlights that there's many factors that actually affect the shortage. Some of them are highlighted there: your gender, your culture, perceptions about the profession, computer experience, awareness, and there's many more. But then in order for us to have, when we're looking at this paper, we needed to be guided by theories that will help us in highlighting those factors. So in the study, we looked at theories and models that have been applied over the years in understanding these factors. And some of the theories that we came across was a social cognitive, career cognitive theory, your theory of reasoned behaviors, and also several IT career models. So in underpinning our paper, we used some of those models and theories, which I'll explain later. So our problem statement was basically highlighting the declining number of IT graduates, which is a serious concern, has been highlighted by literature. So what we aim to do was understanding then those factors. And we believe once we've come to a clear understanding of the factors, then it can enable institutions to produce an increased number of graduates in order to alleviate that demand that is on the job market. So in doing so, we theorized by having 5 questions that we thought were key in answering or in addressing the problem. So we focused on the theories. Number 1, which theories and models are used for career choices. We focused on the factors that influenced first-year students to choose the courses that they embarked on, which I'll delve into each of them. We also focused on the perceptions of the students while they were at school and the information that they received before enrolling at the university and what was their initial career choice before that. And then in our research design, we started, of course, with those questions. We looked at theories, and our literature was driving the study in order to formulate a conceptual model. And then, of course, we had to develop a questionnaire. But in this case, we didn't develop a questionnaire. Based on the literature, we developed a conceptual model, and the questionnaire was there as a proof, or we were testing the validity of the conceptual model that we developed in this paper. So the questionnaire results had been derived from secondary data that had been collected back in 2014. It had similar questions that we were addressing on this paper. It was distributed to first-year students who enrolled for CS and IS at Nelson Mandela University, and it was administered to Question Pro, and that's the ethics number that it went on in the ethics committee. So the questionnaire itself focused on biographical information. It had things that factors that were categorized: your socializers, your learning experiences, career perceptions and expectations, and lastly, it focused on career awareness. So what we did for this paper, we took that data then with those factors, we did a quantitative analysis and qualitative, breaking it down in themes. And this, of course, as we've said, that it's an exploratory study because we're trying to see if the conceptual model really is valid based on existing data. So this was basically some of the factors that helped us in building the conceptual model. And these are the factors that we actually searched on the literature. We focused on socializers, sources of information, learning experiences, career perceptions, theories, in order to develop the conceptual model. So when we focused on theories, which was our first step, answering our first research question, we looked at theories that have been used in understanding factors. And there were several, of course, but then we chose the social cognitive theory on how it's been applied. One of the reasons is that it's been applied mainly in studies in local environment, which is South Africa. And it was used in those 2 papers, which we highlight, that it was used on how to understand personal, cognitive, contextual factors which influence career choices. And then another study that was done in UCT by Prof. Seymour and Sir Mola there, it identifies structural influences that would cause CS students to change their majors. And these were really examples that made us to use the social cognitive theory to underpin this research paper. Then, of course, we looked at models also that have been used and developed over time. We came across the one by Don and Luca, which this one was particularly developed in understanding students' career decision in terms of their plans to take ICT or CIT courses, as they put it, at university. So it was a study done before students could go to university while they were still at high school. And that was one of the reasons that we chose it. And there was another model also by Dick and Rallis, which they published in 1991, which is a model also that focused on the factors that shaped the students' career goals. So these were the models and theories that underpin this research paper. and it guided us to carry on forward. So in carrying on forward, then we could focus on the socializers, and we could look and research how are socializers defined, what are they? So one of the papers we came across, it highlighted that these are predetermined factors or things that will affect a student's career choice. And these are things that would include your stereotypes, job availability on the field. And of course, the job availability was not the key in terms of the career choice for many students. They were mainly focusing on salaries. That's what research shows us, salaries, and things like access to technology at home and at school. Also, there were things that were influencing students' decision at the end. And of course, we could not ignore things like gender, socioeconomic statuses that influence the field. Those were things we highlighted as socializers. And then our next question focused on the sources of information in terms of advice. And some of the data that we came across or papers that we came across, most of the studies show that IT graduates were not familiar with the IT careers or the career descriptions or what the career entails when one is talking about an IT career or a specific field. And papers also, research showed us that other countries had started having initiatives that then promote the IT careers, not only to know the title of a career, but to know what it entails. And then in also looking at this source of information that was more an in-depth look at it, but also where do students get or information or scholars get information about the courses, and research showed us that parents, friends, teachers, and open days, things like brochures, this is where they get information. So we're also trying to find out what is the key or what is the essence of learning experiences. And one of the things that research highlights is that exposure also to programming environments and programming experiences can be a factor that influence students from high school to choose an IT career. One of the papers that was key, which is by Wilcox and Yonell, highlighted that the exposure at high school, even amongst males and females, once they're at university and they've made the decision to choose an IT career, females who had been exposed to programming at school, they tend to perform very well. So we can see that literature tells us then that once you expose one at an earlier stage, then they can do well and make an IT career choice. And then also another paper that supported that, which was Porter, Dalday, found that exposure to technology at an early age, it increased the interest in pursuing IT. And then of course, we looked at career perceptions too and awareness. That a paper that was published by Prof. Kalitz and Dr. Petrotis highlighted that many students were still not aware of what IT career opportunities are out there. And then this was also highlighted in Esther Hayes et al. 2019, that there was a big difference between the knowledge of the opportunities and the actual job that an IT profession has compared to what students would perceive. So with all that information that we had, we formulated or proposed this conceptual model, which highlighted some of the keys factors that we found in literature. You can see socializers, the learning experiences, career perceptions, and also awareness. So in this paper, we focused on the four. We couldn't, our data didn't allow us to focus on the self-attributes. So we focused on learning experiences, socializers, career perceptions, and career awareness. Now, in testing our model, as I've said, we used secondary data, which was distributed a while back, and it was administered to over 205 students. And those students were enrolled for BSc, CS, and become IS within the NMMU Computing Science Department. And that's the demographics in there. So the first point that we focused on in pulling out of the data, that where did the students gather information from regarding the courses that the course that they chose. So many of them, 84%, highlighted that they gathered the info. 84% they gathered it from the NMMU department, open day, parents highlighted, brochures and friends, and of course social media and career counselors and school visits by the department were also important. And then in focusing on that, on who actually provided, so trying to gather that information and in-depth of it. So we see that the data showed us, which was an open-ended question, that friends were key in giving information to students. So they relied more on their peers on what to decide, and then less on the influence with teachers. And again, focusing on the parents, what was the advice? See that many of the parents focused on feelings, that you do what you like. And in terms of the field of study, you will see a few, which was 13 of the participants highlighted that they were told to get an IT degree. So again, parents can be given more advice on the other side, but we'll get to that. Teachers also on the other side, you can see that teachers who gave specific advice about there were 7 that gave specific advice on getting an IT career. So these are people that can be influential, which need to be empowered. And then in terms of learning experiences, this was an open-ended question. We basically looked at what the students, or what was the access back at school. Did they have a computer lab? And 62% indicated that they had, and some, or 31%, had undertaken IT as a subject at school, did CAT as a subject also at school, and interestingly, a higher percentage had computer access at home and also internet. So you can see again the exposure at school level is limited, or was limited, based on the data that we had, which was 31% who did CAT and 38%. So this is another big thing that we can focus on. And then we looked at the perceptions and expectations of the students. And we could see that many of the students, they broke those perceptions. When the question was posed about IT being difficult at school, many disagreed that the subject was difficult, and they changed the most common stereotype that IT is only for nerds, that many disagreed with that. And another information or data that came out here was that IT, many of the students view IT people that once one pursues that, they would receive good salaries, they would get opportunities to work internationally. So these are some of the things that can be used also in promoting IT at high school level. Then we wanted to find out in terms of career awareness, and which careers were students familiar with prior to coming to university. So we listed 33, or the study listed 33 IT professions. You'll see that one that was ranked very high was being a programmer. There's business analyst, game developer, software engineering. And these were the ones that were mainly highlighted or mainly selected by the students. But again, if we consider that data, if they know what those careers entail, that's a question that probably will be answered. And then the studies limitations, of course, the participants were approached after making the choice, because these were first-year students that were already enrolled within the department. So of course, there would have been biases in their responses. And the sample size was also limited. And of course, we could have broadened the scope, that it was not only CS and IS students, we could have included IT. So the paper's aims was to underpin the study on a theory that was accomplished, and highlight the factors which would have been developed through a model which was done. And the only one that was not able to be tested with the data that we had was self-attributes. And the findings then of the paper, or some of the things that literature supports, that such as your socializers, your websites, your families, your parents, are the key influences in terms of students making that decision to choose a career, especially IT careers. And also learning experiences are key, that ones at school or at younger age, they need to be exposed to new technologies, to programming concepts, so that it helps them to choose IT at the later stage. And of course, this paper gave insight then into the first years, how they made their decisions in choosing IT as a career. And this therefore helps us then in terms of future research that can be undertaken, which basically would allow to conduct an extensive study amongst first years, including all groups, IT, CS, and IS, and have a larger sample, whereby use of multiple statistical analysis procedures can be applied, and then more deductions. Thank you. Can have questions, please.
Thank you, Mali, for a very interesting paper presentation. I'm going to hand over to James Connor now, who is our Q&A coordinator, to pose questions to you. Please remember, to all the attendees, that if you have any questions, click on the Q&A icon at the bottom of your window and type in your questions for Mali there. Over to you, James.
Thanks, Ingrid. I'm Mali. Thank you very much for the presentation.
Thank you very much.
I've got a question here for you already, and you your last slide sort of hinted at that. If you're going to continue with this research, how are you going to gather this information with the whole COVID-19 situation next year?
Well, that was the issue that we're sitting with now. How do we collect the data? But I mean, there are many forms that we've thought of already off by head, that we could invite students in terms of a webinar, or in doing interviews over online technologies. We can also still go ahead and do online questionnaires, but in terms of data richness, then that's again something that one would have to think about. But there's multiple platforms that we've already thought of that we can use in terms of collecting data in the future.
Then another question, you mentioned there that 84% of the students got the information from the department, from the NMU department. Does that mean when did they get that information? Before they enrolled or after they enrolled with you guys?
It was before they enrolled. There's a big drive that has been ongoing in the department, and Prof. Kraling and Prof. Khalid have been pushing that they invite students from different schools, high schools in the area, that they would invite them for an open evening. They would invite parents, and they'd also do talks in those schools. So assuming then that most of them that enrolled in the department were the students who were part of those endeavors, so hence the number was high. So there's initiatives like that that the department engages with many of the local schools.
Okay, that was going to be my follow-up question. That is as part of your school outreach program, which it clearly seems to be. Then another question around the same sort of thing with the in terms of access to computers. You had quite a high percentage of students that had access to computers at home. Did you look at what kind of devices was it? Is a cell phone or smartphone, a tablet, and a PC, are they all considered computers, or do you differentiate between those?
Well, in terms of, again, it was a secondary data that we were working with. So
Okay.
I wouldn't clearly state that it was laptops, it was what. But now in our study, we'll definitely venture into that in detail. What type of device do they have?
Okay, and then another question has just popped up here. Should you perhaps ask scholars to participate in the study so that you have them do the questionnaire before they actually come to campus? Would that assist at all?
Well, again, it's what the study would be focusing on. If we want to get the data without biases, as I've highlighted on the paper, that it would be students already who have made the decision. But if we want to compare in terms of the numbers, the students who've made the decision and the students who have not made the decision, then definitely we can venture into asking scholars. But of course, there's time constraints and ethics that one has got to consider. So now the option would be to focus on the students that have made the decisions and try and work backwards. Then in the future, we would have to go to the scholars and get that information. What are they thinking about their future? But now we'll probably follow that approach of working backwards, starting with the ones that have made the decision.
On this slide that you had up there that showed the different careers, where the programmer got 50% score or whatever, I seem to remember you saying something along the lines of you're not quite sure if the students actually know what those jobs entail. Was that correct?
100%, because we've seen also through some of the research that has been published that students are aware of specific careers in IT, but in terms of what the job entails, the functions of a programmer, a few students would know at that level. If I'm saying I want to be a programmer, I'm studying first year, what does it entail? What will I do?
Yeah.
So that's the question.
And so perhaps that is slightly outside the scope of your specific project, but how big a factor do you think it is people not actually knowing what exactly the career is that they're walking into? Do you think that's a big factor for them?
Well, I think it's a nice environment that we're in, that we've got many experienced people, more than I am, that would probably state that many of the students, even at third year level, they haven't discovered, or they don't know exactly what in particular they're going to do, what they want to be. And at first year, it's probably even worse compared to third year level.
I would tend to agree with you. Well, that seems to be all the questions we've got for you at the moment. Thank you very much for your presentation. I'll hand back to Ingrid.
No, thank you very much. Much appreciated.
Perfect. All the best.
Thank you, James, and thank you, Mali, for your presentation. Much appreciated. Our second presentation now is a paper by Jakob Greef and JT Janse van Rensburg. The paper is titled Exploring Essential Software Development Skills for the South African Job Market. This will be a video presentation. So our Sacla Zoom account is going to play a pre-prepared video for this. And then both Yapi and JT are available after the video has played in order to engage with questions and discussion. So if we just give our Sacla Zoom account a couple of seconds to load that and to play the video for us.
Good afternoon. My name is JT Janse van Rensburg and my co-author is Jaapie Greef. We are from the School of Computer Science and Information Systems at the Northwest University's Vanderbijlpark campus. Jaapie and I share a passion for ensuring greater alignment between what is taught in IT higher education and what is required in the IT industry. For this reason, we collaborated on this paper entitled Exploring Essential Software Development Skills for the South African Job Market. So let's take a look at the research problem. The skills gap between higher education and industry is an ongoing problem experienced in all fields of study. A number of studies highlight gaps in the technical skills and soft skills of engineering, computer science, and information technology graduates, questioning the employability of recent graduates in South Africa, and critiquing the students' abilities to make an effective contribution to the workplace. Even though this is an ongoing problem, limited research could be found that highlights the specific technical software development skills that South African IT graduates should be proficient in, as well as the manner in which these skills should be grouped for maximum impact. In a 2019 South African survey by professional bodies Johannesburg Centre for Software Engineering and the Institute of Information Technology Professionals South Africa, the authors indicate that the ICT skills gap is growing in South Africa and that we may need as many as 50,000 ICT practitioners in the short to medium term. The survey further indicates that employment opportunities in the IT sector of South Africa are not necessarily sparse, but instead that employers have difficulty in filling their IT positions with skilled candidates. For this reason, we wanted to identify which software development skills are currently in demand in South Africa so that the results can be used for consideration in IT curricula and specifically in IT capstone projects. Our primary objective was then to determine which technical skills related to software development are most sought after in the South African job market. Looking at CompTIA's international IT skills gap survey and also echoed in the South African ICT skills survey, the top fields where IT skills gaps are identified are in artificial intelligence, automation, cloud infrastructure, cybersecurity, software development, and the management of big data. Specifically in South Africa, the IT skills gap survey indicates hard to fill vacancies in IT, such as software developers, computer network and system engineers, system analysts, security specialists, business analysts, and database administrators. From multiple sources ranging from academic literature and surveys to the websites of South Africa's top IT employers, we found that some of the important technical platforms and related skills in South Africa include Java, C#, Python, JavaScript, SQL, system integration, design patterns, and source control. The reason all of this information is important is because of the impact on IT higher education. While academics continue to attempt to bridge the gap between IT higher education and the IT industry, there is still consensus in the industry that universities are not preparing students for current IT jobs. Some sources go as far as to say that university degrees may soon no longer be the option, as specifically for a field such as IT, the underpinnings of the craft can be learned from freely available resources. The future of higher education is challenged by professional certifications, internships, and on-the-job experience. Many studies on teaching and learning practices have suggested a variety of methods towards bridging this gap, but we propose that it is not necessary to change module outcomes if you have flexible curricula such as capstone projects. We simply recommend the use of capstone projects that include the sought-after software development skills that are currently in demand in the IT industry. In order to make a start towards this initiative, we explored the IT job listings of PNet to determine which vacancies are hard to fill positions, with the idea that hard to fill vacancies are the positions and skills we should be giving more attention to in IT curricula. And with this, I hand over to my colleague Yapi to explain the research methodology followed for this paper.
As this was an exploratory project, the research design and application design moved hand in hand. The goal was to scrape job listing information and extract from it what sorts of technologies are most useful for students to explore after or even during their studies to make them more appealing to the market. The application was developed iteratively so that data could be collected, processed, and analyzed in a way that was most useful to reaching the end goal. This version of the application forms the first prototype in a design science research process that will be used going forward with the work. Once the application was developed to a suitable point, a large scrape was undertaken to explore what could be done with the application in question and to explore what processing and analyzing capabilities would be useful in future iterations. The final approach was therefore found iteratively and comprised of 4 not entirely discrete steps, namely, performing a web scrape to collect data from job listing portal, filtering and tagging this data to, in one step, remove listings that were not applicable to the kind of jobs being sought, while simultaneously tagging the jobs that are relevant with technologies, processing the data once tagged by using suitable algorithms, and then compiling reports of the processed data so it could be used for decision making. The application is written in such a way as to allow other users to use the same scraped data to analyze other characteristics, like, for example, soft skills. The data that was scraped was obtained from the South African jobs portal PNet and was collected by searching for all positions in the Gauteng and Northwest provinces that are in the IT and telecommunications area. The generated URL was then put into a Python script that used URL lib and Beautiful Soup 4 to extract all of the position-specific information for each listing that had a link generated to it. The scraped data was saved as a pickled data frame for traceability. In the next iteration, this will probably be moved to a database, but since the data was analyzed in the data frame, there was little value in adding it to a database at this stage of the project. The scrape is stored separately from the filtering and tagging session information so that it can be reused for different filtering and tagging sessions where the focus would be different to this one. In this instance, the data sort was specifically related to programming positions. Once scraped, the data frame is fed into the job coding application where it can be filtered and tagged. The application shows all of the relevant information about each job listing, while also presenting a simple interface to allow users to page through the listings, create new tags, mark listings with tags, rename tags, and remove listings from the session, which is also called filtering. Additionally, it is in this application that the clustering and reporting capabilities are housed in separate tabs. Using this application, the 988 initially scraped positions were pruned down to a final list of 413 positions that represented only positions for programmers and similar technical positions. The filtering and tagging happens at the same time and is also stored in a session data frame so that the initially scraped data is not modified, so that it can be kept for later use as well as for traceability purposes. Once the listings have been suitably filtered and tagged, the clustering can be run. The meta parameters for the clustering algorithms are set in the application, and any technologies that should be skipped in the clustering step can be filtered out by simply selecting a tick box. This allows the positions to be clustered without very frequently occurring technologies dominating the clustering, as, for example, SQL is a very frequently occurring technology that matches up with a variety of different programming languages. Filtering out SQL forces the clustering algorithm to search for other, more subtle similarities. The clustering process is as follows. The session data frame consists of the job listings as rows in the data frame and each of the technologies as features. The presence of a technology in a job listing is indicated by a 1 and the lack of presence by a 0. The data is clustered using binary matrix decomposition algorithm. This is a clustering algorithm similar to more famous clustering algorithms like the k-means clustering, but is used specifically on binary data. After this algorithm is run a number of times, classes are identified that listings fall into. These classes are then turned into histograms that indicate how relevant their top technologies are. And finally, any duplicated classes that are found are removed. This process will be described step by step in more detail in the following slides. The first step in the clustering is the binary matrix decomposition algorithm. The algorithms start by selecting a random layout of classes and then seeing which features would then be assigned to those classes, and then creating a second matrix that has only the class features assigned to each of the rows. The difference between the data being clustered and this random initial layout is then taken as the error. From there, the algorithm tries to select new features for each class and by doing so minimize the error. In this process, the algorithm indicates the features that are characteristics of a class. For example, a class may have as its class features C#, SQL, MVC, etc. as its class features. A feature is considered a class feature if it is present in at least 50% of the members of the class found by the algorithm. Binary matrix decomposition, as all clustering algorithms, is susceptible to the initialization problem. The initialization problem is that since the clustering algorithm starts with a random guess of the layout, it then tries to minimize the error from there. It will give different results every time the algorithm is run, as there are multiple ways in which the data can be clustered, and it is dependent on the starting position of the random guess as to which classes will be found. In this instance, however, this is a beneficial feature and not a disadvantage. As with all clustering algorithms, the assumption is made that rows cannot be in more than one cluster. For our purposes, however, we definitely want listings to be able to fall into every different kind of class that they can logically be mapped into. For example, A job listing may request knowledge in C#, SQL, and MVC. Two classes may be found via clustering that have as their shared features C#, SQL, MVC, but then additionally need knowledge of JavaScript, Git, and Power BI in one, and Hadoop, Scala, and Elasticsearch in the other. In this situation, the listing should be able to fall into both of these classes. For this reason, the clustering algorithm is run over a number of iterations, and all of the classes found are collected after each iteration. In the next step, the classes that are found by the clustering algorithm are turned into histograms indicating how relevant each technology in the class is. As was indicated previously, the binary matrix decomposition algorithm will count a feature as a class feature if it is found in at least 50% of the members of the class. For our purposes, however, we would like to know exactly how relevant each technology is to each of the classes that are found. This is done by counting the occurrences of each of the top X technologies or number of technologies and using these to characterize the class. X is one of the meta parameters that can be set for the clustering process. An example of this histogram is found on the following slide. In the slide, a class is presented that is relevant to 128 of the 413 listings in the session. The top 15 technologies are chosen in the meta parameters. From this, we can see that SQL, MS SQL Server, is relevant to more than 90% of the listings that were found to be members of this class, with the other 14 technologies all having their relevance indicated in descending order. The relevance is calculated by simply counting the occurrences and dividing by the number of listings that are found to be in this class. Once all the classes have been identified and turned into histograms, they are compared to each other and duplicates that are found are removed. As we are running through a number of iterations, it is possible that some of the random starting positions will still identify the same classes as were identified previously. This duplication removal process is done by taking each of the classes across the most relevant technologies and comparing the percentage relevance for each feature. This is done by using mean squared error, which means that the difference in relevance for each feature is squared and the average is taken across the top X technologies for each cluster. For example, if C# is 95% relevant in one class and 87% relevant in another class, the difference is 8%, which is squared for a value of 64. The mean squared error of each class with relation to every other class found is then loaded into a data frame and a count is kept of similarities. Once all mean squared errors have been calculated, k-means clustering is used to group together classes that have the same profile of mean squared error comparisons. This is done to discriminate in the situation where mean squared error falls just outside of the 5% range, but still matches the same shape when compared to other classes, as well as to discriminate between those classes that have a 5% match, but then match completely differently when compared to other classes. In future work, it will be compared whether this gives a significant advantage over simply using the mean squared error approach only. For the data that was analyzed for this paper, scraped on 8th of October 2019, the following metaparameters were chosen. Classes would be allowed to be, that were of size 1 would be allowed, therefore allowing situations where a listing that is completely different to everything else could still be found. 7 classes per iteration of the binary matrix decomposition. 15 technologies would be used to compare with the mean squared error duplicate check. And the binary matrix decomposition algorithm would be run for 250 iterations. With these metaparameters, 69 different classes were identified and published in an automatically generated report. In addition to the clustering report that is generated using the metaparameters, the application also has the capability to run other reports to compare technologies with one another, as well as to indicate the amount of association there is between technologies. The technology association report requires the user to indicate the number of associations wanted and then to choose a technology. The application then generates a spider diagram that indicates the top X technologies associated by that report, being the technologies that show up the most in listings along with the chosen technology. In this example, Java is chosen as the technology and the top 14 technologies associated with it are indicated. Technology comparison reports are drawn to see the number of occurrences of each technology chosen so that they can be compared to one another. This was the report used to also logically group together the technologies that, in the author's opinion, were of a similar nature. In this example, all of the programming languages were found were grouped together and plotted. This is, however, not the only way in which the report can be used, as there is no limitation as to what technologies can be run next to each other. This was just the most useful approach of it, in the author's opinion. After evaluating this version of the application, the following recommended changes are proposed for the next iteration of the application. It is proposed that it should be moved to Django instead of remaining as a Qt5 application. The choice of platform was initially done simply because the author wished to explore Qt5 in the Python context, but in order to make the information more accessible to students, it is proposed that it should live online instead. This initial application of the work was done with programmers in mind, because this is what was most relevant to the subject taught by the author. But it would make more sense to train staff members in the Career Center to use the application so that it can be applied to other fields and specializations as well. The number of iterations that the binary matrix decomposition was run was adjustable, and 250 iterations was found to give a good amount of classes. But in the next iteration, it would be more useful to have the capability to let the algorithm run until it doesn't find any new classes for X number of iterations, where X is a metaparameter. More metaparameters are also needed for the mean squared error comparison step. Specifically, it should also compare classes by size, and similarity scores should be adjustable rather than being fixed at 5%. It is also currently the case that the algorithms run in a single step, which requires a fair amount of computing time. It would be more useful to allow the clustering algorithm to run and have the intermediate data stored so that the similarity check can be run with different metaparameters.
So what does all of this info mean? From our results, we identified 20 technology categories such as programming languages, database technologies, data reporting, cloud, and enterprise software, to name but a few. For the purpose of our paper, we focused specifically on programming languages and database technologies. We identified 32 programming languages in the job listings. The histogram indicates the number of times the specific programming languages were requested in the job listings. From the diagram, we can see that HTML5 with CSS3 and JavaScript is most in demand, followed closely by C#. In terms of database technologies, 19 database platforms were identified from the job listings. The histogram indicates the number of times the specific database technologies were requested in the job listings. From the diagram, we can see that MS SQL Server is the most sought after database technology, indicating that skills with this platform would be highly beneficial. Other valuable information we were able to highlight from the results are the technology association graphs. With these graphs, we can visually see which technologies are most often grouped together. For example, when referring to software development skills in Java, the association graph illustrates that a Java developer would typically need to be knowledgeable in HTML, CSS, or JavaScript as well. When reviewing the C# association graph, we can see that a C# developer would typically be expected to be knowledgeable in SQL or SQL Server as well. The novelty of the association graphs are what we call skills baskets, which can both be used to make sure that when planning student projects that related technologies are required, and also if students have a preference for a specific programming platform, the association graphs can indicate which other related technologies they should be focusing on to ensure that they have the correct skill set. In the study, the top software development skills that are most in demand currently in the Gauteng and Northwest provinces of South Africa, among others, are SQL, MS SQL Server, HTML5, CSS, JavaScript, C#, Java, Angular.js, .NET, ASP.NET, MVC, which is a design pattern, and Git, which is a source control platform. It can be suggested that the skills that are currently most needed in the IT industry in these regions are database administration or integration in relational database systems and software. Development in web-specific projects. This is supported by the fact that HTML5, CSS, and JavaScript skills are the most sought after programming language skills. Additional emphasis was placed on advanced skills such as using design patterns like MVC and software development platforms such as Angular.js. The novelty in this paper lies in the identified software development skills that can be emphasized for inclusion in South African higher education IT curricula. By identifying these skills which are most in demand in the IT market, two problems can be addressed. The first of which is that IT employers have hard to fill vacancies due to skills shortages in software development. The second being that IT graduates do not necessarily receive training in software development skills that are currently relevant and essential for today's IT job market. The identified skills in this paper can be included in exit level modules or capstone projects to ensure that future IT graduates have completed projects using skills that are currently in demand. Another novelty of the paper is the research approach, which can be used in any field of study to perform web scraping and analysis of current market needs, which in turn can inform related higher education instructional approaches. That concludes our presentation. Thank you for your time.
Okay, that was a very interesting presentation, and we'd like to thank Yapi and JT for pre-recording that for us. Both are available now for a Q&A session, and I'm going to hand over to James as our Q&A coordinator.
Thanks, Ingrid. JT and Yapi, the first question I've got here for you guys that popped up here is, what package did you use to analyze the data?
So, hi, and I think I'm going to give over to Yapi to answer the research methodology related questions.
Okay.
Okay, so the packages were varied. BMD cluster is a Python package that you can freely download, which is for clustering data, or for clustering binary data specifically. And then the bulk of the rest of the stuff came from scikit-learn. There's also some work that I'm playing around with in TensorFlow, but that didn't form a part of this paper specifically.
Okay, thanks. The next question, unsurprisingly, comes from an anonymous attendee. It says they noticed the background in your presentation was a bar. Was this recorded during lockdown?
Yes, this was recorded during lockdown, and at that point in time, my laptop was on the dining room table, which has the bar behind me.
The next question, and sort of this was something I was going to ask you anyway, is the comment is that the skills basket idea is very nice. It's quite an interesting idea that you're not just one specific technology, but a whole group of technologies. The question is, are those spider webs in your paper?
So two of them are in the paper, but because there's actually quite a number of them, as I say, we identified 69 classes, and each of those could be a spider diagram. So we took the two main ones, which were Java and C#, to introduce, but we're busy on another paper to just give a bit more of an overview, to reference back to the methodology in this paper, and then present just the data in that paper.
And then someone notes here that something that's interestingly missing from your diagrams is blockchain technology, something that you hear about so much. Why do you think that is not there at all?
So there's a lot of stuff that I think came up in general as themes that people think would be very important. So people talk about artificial intelligence being really important. But when you look at the specific jobs people ask for, those are not specifically technologies that they're actually asking for in the market right now. So we specifically took the view of looking at the market in the provinces that were relevant to our university specifically, to try and see exactly what is asked for so that the students can upskill themselves in those technologies.
Then something that struck me while I think during your part of the presentation, you gave a very specific date on which you scraped the web. How long does it take to do the scraping, and how much do you think things will change in subsequent scrapings?
So the scrape is pretty quick. The scrape took about 35 minutes to cover everything, but then obviously tagging it takes a bit longer, because that obviously requires someone to go through and tag whatever they feel is relevant for their specific search. So that took about 4 days for this specific scrape. But that was also because none of the technologies had been tried before. So this will obviously be much faster as you do follow-on scrapes after that.
Okay, then another question just popped up here, says, can't we say Python is overtaking JavaScript, given how data science seems to be taking over and most people are using it for machine learning?
Again, that is not something that comes out in the job listings we found that are specifically relevant right now. Those are general trends, and I think also very international trends where people are saying, oh yes, this is a great technology that's coming up, but we're specifically looking at our graduates and the market that they're going to step into right now. And for that, there wasn't nearly as much call for that as things like JavaScript.
Okay. Ingrid, how are we doing for time here? Do we have time for more questions, or?
We do have time.
Okay, now I just want to check. I mean, there aren't any more as it happens, but I just wanted to make sure.
I have one actually.
Okay, go for it.
I was wondering, what would you say in response to someone who was a naysayer, saying that curriculum in an academic department should not be so heavily influenced or guided by industry requirements? You know, we've heard before, you know, people making claims like, oh, we shouldn't be chasing trends. So what would your response be to someone who, you know, is a lot more cautious about using an approach like this?
So I'm going to answer, but I'm also going to give JT an opportunity to answer, because I think she has very strong feelings on this. For me, this actually forms part of a slightly wider project where I'm looking more at students that graduate right now, and what do you do for the 6 months after your graduation. So we're targeting specifically capstone projects where we don't necessarily change the underlying courses, but capstone projects have them a bit more focused on new technologies. But for all the technologies identified, it's useful to also have a list of MOOCs that are available to specifically give to students to say, you've just graduated. If you're interested in this specific skills basket, here is a list of MOOCs that in your own time you can now use to upskill yourself to be, you know, applicable to the market. So this doesn't necessarily have to happen in the university context. This is something that we want to make more freely available to our students so that they can use their own time to now research these things with more guided knowledge. JT?
Thanks, Ingrid, for the question. I think the first comment I can make is that from our literature, as I've indicated, that there are a lot of resources now coming up saying that university degrees might in the future no longer be the thing that students will chase, because they can get the skills essentially from professional certifications and mentorships and stuff like that that companies are giving at this point. So we have to update and follow in line to actually give in the industry some skilled candidates. I'm really passionate about bridging the gap between university and industry, and I've spent the past 3 years working on my PhD towards this goal. So I can only say that it's been a positive experience when collaborating with industry members. And we can also see this from the previous paper that was presented, the comment that James made about whether the students actually know when they say they want to be a software engineer and this and that, whether they actually know what they're going to do. And the only way we can actually tell students what that is if we have insights from industry. So, and also from Prof. Stahl's presentation this morning on industry advisory boards, if we don't have input from industry and take guidance from what is required in industry, then what's the point of us trying to train students for employment?
I think that's you have my wholehearted agreement. I feel the same, but it's something we hear often.
One of you mentioned the doing this with a career center. I can't remember the exact phrase you used, but making software like this available to people like that. How much I mean, obviously you guys have a solid computer science background, and you need to do the categorization of the tagging before you can feed into your system. How much of this can you do with other subject areas? So if you wanted to apply this to not computer science or IT or whatever, how much knowledge would the person need of the field in order to be able to use this for, say, whatever, physics?
So the reason we made the reason it's a custom application is specifically to try and facilitate that exact situation. So the next person that's actually using the scrape data that I grabbed in October is using it from the communications perspective. So a BCom communications background to say, you know, what things are relevant to that specific field of study. So it doesn't necessarily need to be technologies. Those tags are completely generic. So you can tag it with whatever you think is relevant, and it will generate the association graphs, and all the clustering is done basically for you.
But you need an expert to tag.
I would say you don't need an expert, but you need someone that will recognize when something is a requirement for a job. So if it's something like accounting, you would need to know that some reporting standards are, you know, relevant. So that's why we're specifically targeting the Career Center, because they are associated with each of the different schools and have some understanding of what those requirements are. But it does require some training, yes.
I see we're being told to stop so the next person can come on, but that sounds like a nice classification problem for future studies. Anyway, thank you very much.
Thank you very much for the time.
Thank you. Thank you.
Okay, thank you so much, James. Thank you, Yapi, and thank you, JT. It was a really interesting paper. Obviously got lots of people asking questions, but we do need to move on. And we're now going to hear from our third presentation for the afternoon. This is a paper by Andrei Karlitz, Lester Cowley, and Sue Petratos. A paper is titled A Proposed Structure for Managing IT Diploma Programs in South Africa. And the presentation today will be done by Dr. Sue Petratos. So if we hand over to Sue, is she with us?
Yes, I am here. Thank you very much.
Pleasure.
All right. So this afternoon, I'm going to be talking about the proposed structure for an IT diploma program content in South Africa. This paper was co-authored by myself, Prof. Andrei Karlitz, and Lester Cowley. The presentation will follow the following topics, and at the end I will recommend a way forward before concluding with this presentation. If you see, the literature review has got quite a background with regards to the history and where we have come from. So I'm going to start off by just touching on how this whole paper came about. So the study was born from informal chats between lecturers at various institutions. These informal discussions grew amongst lecturers at institutions that offered, in particular, non-degree IT qualifications. At Sacla, held in Cape Town in 2018, one of the sessions were dedicated to discussions about where these institutions fit in and how they were represented in forums such as Sacla. The ongoing debate around diplomas versus degrees and the relation to one another was also raised. At this point,
Sorry,
Prof. Karlitz, yes.
Sorry, I'm sorry to interrupt you. We just wanted to check, do you want to share slides? Because you're not actually doing it at this point.
I am should be sharing. Just one moment, let me go back.
Okay.
Maybe I'm sharing the wrong screen.
Well, actually, at the moment, we only see you.
Okay, sorry.
No worries.
This is the screen here. Anything there?
Yes, perfect. Now we get it. Thank you so
Okay,
much.
great. All right, I will just continue from where I am. All right. So as I said, the background discussion came about from some informal discussions that were held with various lecturers from institutions, and in around 2018, Prof. Karlitz and I realized that we need to actually take this forward and turn this into some formal research and do a proper paper and background studies on this. So the problem that arose was that currently there were no existing bodies that ensured the standardization of curriculum content and quality assurance standards for IT diploma and IT advanced diploma programs. The objectives of the study is to identify IT diploma and advanced IT diploma programs, to determine the support for the establishment of a South African IT Diploma Advisory Board, and then also to propose an establishment of such a board with also a rationale and process for drafting guidelines for an IT diploma and advanced diploma program body of knowledge for South African universities. So the methodology included a literature review, as well as an email survey, which was done amongst the various institutions that offer the diploma programs. And thereafter, themed data analysis was conducted. The literature review included historic overview of the higher education landscape in South Africa, also looked at the review of academic accreditation bodies for IT qualifications, and then a desktop study was done of institutions offering diplomas. So let us first have a look at the higher education landscape. The current South African higher education landscape was implemented in 2005. And many of us sitting here today have gone through different levels of difficulty in going through the transformation that was required at that time. Just coming back to the landscape then, there are currently 3 types of universities, namely research universities, comprehensive universities, and universities of technology. Comprehensive universities were created through the amalgamation of selected research universities with technikons. Before 2005, technikons were responsible for offering diploma programs. There are currently 26 higher education institutions in South Africa, of which 6 are comprehensive universities and 8 are universities of technology. A total of 26 IT diplomas and 9 advanced IT diplomas are offered at these various institutions. This slide, as well as the next one, shows the institutions that offer diploma qualifications. Prior to 2005, a generic national diploma was offered by the technikons. However, post-2005, most universities, comprehensive as well as universities of technology, have tried to introduce a bit more of distinction amongst the diplomas that they offer. And this was to allow students to access the various fields of IT and to distinguish the expertise and the specialization areas that existed in the institutions. So it's no longer a national diploma with constant content. It rather is more diverse and still focused on the specific expertise in particular institutions. However, having done the literature review, we did find that most of the universities still focus on software development as well as communication networks for their diplomas. With the rapid changes taking place in technology, the question arises regarding the content management of these qualifications and the monitoring of the standards of the qualifications. I will quickly highlight the historic role of some of the IT bodies that I have mentioned previously. Okay, so first of all, if we have a look at Sacla, this is a formal association that was founded in 1971. It consisted of all professionals that were involved in computer science, systems, information technology, and other IT-related institutions. The main activity of Sacla is an annual conference where issues concerning teaching and research in IT education in Southern Africa are discussed. At the Sacla conference AGM in 1984, there was a disagreement between the institutions where academics were teaching IT-related degrees and then academics that were from technicons that were teaching diploma programs. This argument resulted in the academic members from the technicons in South Africa disassociating themselves from Sacla. They then established a separate body with similar aims called the Technicon Computer Lecturers Association, or as we know it, TECLA. This was in 1989. TECLA, however, ceased to exist in 2005 when the South African government changed the higher education landscape. A new body was formed in 2006 called HICTA, the Higher Education, Information and Communication Technology Association. However, having done some research, it was not possible for us to find information dating later than 2013. So it seems as if after 2013, the members have not met annually and the HICTA was not active. Currently, all academics from all universities involved in IT education in Southern Africa are part of Sacla. Just going back to the program accreditation, because this is where one of the questions came in when we were having our discussions, how does one actually ensure that the diplomas that are currently being offered are up to standard without having an overseeing body? So looking at internationally, the Seoul Accord is an international agreement for professionals and is involved in accrediting IT technology academic programs. It is a worldwide organization and exists and was started in the countries that are listed here as the main countries: Australia, UK, Mexico, etc. The IEEE has its roots as far back as 1884, but more recently, there are members in 160 countries, and through its global network of geographical units, publications, web services, and conferences, the IEEE remains the world's largest technological professional association. The ACM is based in Europe, India, China, and other countries, which exceed the hundreds across the world and particularly focus in qualification standards. Now, if we move to locally, SACWA was established in 1995 as an interministerial task team to review the national qualifications framework of South Africa's education system. More recently, the accreditation of IT-related degree and diploma programs is managed by the South African Computing Accreditation Board, SACAP. This was commissioned by the Institute of IT Professionals, and we saw Tony speaking today, as well as Sacla, which is affiliated to the International Federation for Information Processing, or as we know it, IFIP. With all of these bodies in place, we had to establish if there was actually indeed a need for a South African IT Diploma Advisory Board. So therefore, we had a look, we had to conduct the study. We are just going to have a quick look at the offerings that exist and how they are currently structured. Okay, so a desktop study of the institutions that are currently offering diplomas was done, and this was done by looking at the websites of these various institutions. A summary of the diplomas offered was created in this graph here. And as you can see, the most popular IT specialization programs that universities offer are software development, information technology, communication networks, and support services. Moving on to the desktop results for advanced diplomas, the advanced diploma in information technology was the one that far exceeded the offerings in the other fields. However, it was also closely followed by communication networks. Okay, having a look at the survey results in more detail, we needed to determine what was offered at institutions and how the offerings that they currently have was determined. So as mentioned, there is no longer the national diploma of information technology, but rather that has changed to just the diploma of information technology. How these diplomas were offered, or how it was decided on what to offer, was basically based on what institutions already had in place, what resources they had available to them, and as far as we could understand from the survey, what national diplomas were in place also played a big role, as it was often just taken over from the national diploma, switched over to the normal diploma, or to the new diploma, I should say. Some of the institutions indicated that they also consulted with their advisory board. If we look at how the content was structured, the respondents indicated that the IT diploma programs are still based on the old structures of the national diplomas. The respondents also indicated that they have workshops with academic stakeholders and a curriculum specialist to advise them on program content. When asked about the extent of collaboration between institutions, we were told that the collaboration was minimum and that institutions' websites were visited for information, but that direct communication was often not had with people from various institutions. In some cases, academics were consulted on deciding on the structure and the content of the diploma programs. One institution indicated that they did have a look at offerings from overseas universities. However, we found that most of the content was still just taken straight from the national diploma. How do they ensure that the current content remains relevant? Some institutions make use of input from companies such as Cisco, which provides major input to the diploma program, specifically the ones offering the communication networks. It was also indicated that recurriculation processes take place at institutions quite regularly. And by regularly, we were told that most of this is indicated as being a 3-year period. Advisory boards, as well as academics with specialization areas, were also consulted to make sure that the content remains relevant. But we have just heard from the previous speaker as well that there needs to be a little bit more done to ensure that when our students do go out there, they are actually ready for the workplace. So while external examiners and moderators and advisory boards are also used as methods of ensuring that the IT diploma program remains current, there definitely still seems to be that there needs to be work done here. With regards to the quality of the program, again, this exercise was undertaken at various stages, mostly also indicated to be something that happens on a 3-year cycle. Some universities have got a quality promotions unit or a quality assurance unit, and these are used to ensure that the quality of the different programs is up to standard. It was also indicated that employing academics with the relevant qualifications further assisted with quality assurance. The important role of the advisory board was also emphasized by many of the departments. Some institutions indicated that they do not collaborate regularly with other institutions. So with regards to keeping the content relevant. The use of external examiners and moderators also assisted with the quality of the program, and also was found that they were helpful in keeping the content relevant. when our surveyed participants were asked about the fact that, you know, would they support a South African IT advisory board, and also if they would propose that there should be a general body of knowledge created for the diplomas, all but one institution was in favor of going ahead with the South African IT Diploma Advisory Board. The advantages that were listed for such a board were the recognition of qualifications offered by other institutions would allow students to transfer easily between institutions. Students would also be able to complete outstanding modules through institutions offered at distance educations. And also with this process, or sorry, this board would assist with accreditation and review processes, and also ensure that standards at all institutions are adhered to. Having a qualification that is recognized and that is content is recognized and quality assured will also assist with the employability of the students. The proposal, therefore, is that whilst many international institutions exist that assist us with making sure that our content and our quality of our programs are up to date for our degree programs, it seems to be very much lacking for diploma qualifications. So the proposal is that a South African IT Diploma Advisory Board be created. This advisory board should consist of all universities of technology as well as comprehensive universities that offer the diploma program. It's also proposed that a body of knowledge must be created that the South African IT Diploma Advisory Board must look at and accredit for IT diplomas as well as advanced diplomas. The idea about the proposed program structure and body of knowledge is listed here. Again, this will be created and worked with through the South African IT Advisory Board for diploma institutions offering diplomas. Although we are having this body of knowledge, we still need to ensure that there is movement for universities to be able to still hold on to their identities and offer unique programs, whilst at the same time having some basic common understanding about what it is that a student needs to have when they exit an IT diploma. So the idea is that there would be a common first year diploma, and then there would be a core diploma specialization areas for students to select, and elective diploma modules and elective and core advanced diploma modules. All of these, of course, have to be NQF compliant. So in conclusion, 12 higher education institutions offer diplomas and advanced diplomas with little to no collaboration for standards and quality assurance. The survey results supported the creation of a South African IT Advisory Board, and this board must represent universities of technology and comprehensive universities. There's also a need for an IT diploma body of knowledge. This must also remain diverse to give institutions an opportunity to specialize in the area that they actually have resources for. So thank you very much for listening and for the time.
Thank you so much, Sue, for a very informative presentation. I'm just going to hand over now to James Conlon, who's going to field questions to you posed by attendees.
Thank you.
Hi, Sue. The first question I've got here for you is the South African Computing Advisory Board will join the Soul Accord through the Institute for IT Professionals South Africa. Does the Soul Accord cater for diploma programs at the moment?
We seem to have lost her.
Lost Sue.
Yeah.
I don't see her either.
Perhaps you just need to give her a minute or two to reconnect.
Okay. Yeah, she's not on the participation list anymore. Someone's trying to contact her, but come on, Ingrid, why don't you just answer the question?
Okay, we seem to have promoted Andre to a panelist, and he is one of the co-authors. So perhaps Andre can answer the questions for us.
I see Andre on the list, but I don't see him on the screen yet. Okay,
It also appears that Sue
back.
is trying to rejoin.
I'm sorry, I'm back now. I hope Andre was able to assist.
Not a problem. We haven't been able to hear Andre yet, so I'll just repeat the question to you.
Okay, thank you.
The South African Computing Advisory Board is joining the Solar Court through the IT Professionals of South Africa. Does the Solar Court currently cater for diploma programs?
We have not noticed diploma programs in most of the discussions that we've, or most of the research that we've done. Emphasis is always seems to be on degrees. So we need to find a way of, ensuring that the diplomas are also recognized.
Okay. Then the next question is, will you consider allowing private universities to join this new board?
I think it's a good idea that we do that. It was not part of our initial, undertakings. We also didn't look at things like TVET colleges who also offer diplomas. So those were not looked at all. I think it will be a good idea if we can have a good, comprehensive participation in this.
Okay, and then the next question kind of leads into that. If you do have this in place, do you think it would make it easier for students to move between different institutions?
That's definitely one of the ideas, that at least, we can have some kind of mobility for students to be able to move between institutions. They might need to make that decision perhaps after their first year. It might not be that easy after their second year or third year when the specialization areas, are unique to institutions. And that is why we said that we do want to have a core content, but we still want to have universities have their own identities.
Okay, thank you very much. Those seem to be all the questions we have at the moment. Thank you for getting you back. If there's anybody out there that wants to pop up a last minute question, by all means do, while we've got Sue here. Otherwise, thank you very much from our side.
Thank you very much.
Okay, thank you very much, Sue, also from my side. And I want to take this opportunity to thank all of our presenters this afternoon. These have been very informative presentations, and we've had some really nice and a good discussion, which has been fantastic. And so this marks the end of this afternoon's proceedings. And so we shall see you all again tomorrow morning at 9 a.m. And we hope you have a lovely afternoon further and a pleasant evening. Thank you for joining us again.